In almost all embedded applications, one LCD is used to display a variety of information. For example, a cell phone, MP3 player, digital clock, etc. This helps user to read a clear message instead of reading LED status and remember the meaning of each LED. There are various types of LCDs available. We will be using a commonly available and widely used 16 characters by 2-line alphanumeric display. This LCD is provided with your experiment board. LCD is itself an embedded application. If you look at the back side of LCD, you will notice 2 black bumps on the PCB. These bumps hold some embedded microcontroller device inside. These embedded chips controls each dot on the LCD screen. As an AVR programmer, you should understand the command format necessary to instruct these embedded chips to display what you desire. Thus, when you buy a new LCD, ensure that you are aware of its command format. These commands are described on the LCD datasheet. The command format required by the LCD supplied with your experiment board is displayed on your screen. Next screen will explain you as how to use these commands and circuit details of LCD. The LCD provided with your experiment board has 16 pins for connection. Hold the LCD with the display panel facing you. You will find these 16 pins on the top side. The leftmost is pin number 1 and the rightmost is pin number 16. Pin number 1, 2 and 3 are used for power supply to LCD and character brightness settings. Pin 4, 5, 6 are function selection pin. Pin 7 to 14 are the data pins. These pins are used to feed the data to be displayed on screen. It is also used for passing command values to the LCD. Pin 15 and 16 has to be connected to +5 volts and ground respectively, only if you want to use a LCD backlight. Command values to LCD can be sent in 4-bit or 8-bit format. If we use 8-bit format, then in total 11 pins of your microcontroller gets engaged. But using 4-bit format drops the pin usage to 7. We will use 4-bit format in our application. You may refer to the user manual of the experiment board for LCD connections. Let's move on to the next screen to understand source code. Refer lcd.h file from the sample source code folder for AVR. To simplify the understanding, red color source code indicates the control line connection. It configures PD4, PD5 and PD6 of port D as control lines. These pins of Omega32 will be connected to the RS, RW and EN pins from LCD respectively. The blue-colored source code indicates the data port configuration. We have used PDO, PD1, PD2 and PD3 as data port. These pins of Omega32 will be connected to the D4, D5, D6 and D7 pins of LCD. Remember that we are using 4-bit format to communicate between LCD and Omega32. To use 4-bit data format, ensure that you use the higher 4 bits of LCD to connect to Omega32. The higher 4 bits of LCD are as D4 to D7. Use this header file to configure your connections. Include this header file into your application main.c file as shown on your screen. You have to change your make file, so to use the lcd.c file. lcd.c file has all the necessary function required to initialize a LCD. Clear LCD screen, display characters on the screen, etc. Look at the highlighted line from the make file. Include the .c file here. In future, if you have any additional .c files, you have to list them in make file as src value. By now, as you know the connection details and files related to LCD interfacing. It's time now to start communicating with LCD using the function available from lcd.c file. First line on your screen demonstrates the LCD initialization routine. Second line clears the LCD screen and third line displays the text voltmeter. If you want to display the text at a particular location, then use the fourth line of code with 2 parameters. The first parameter indicates the character position where the second parameter is used as line number. Due to the function call with parameter 5 and 1, the hello text will be displayed on a 6th position on the second line. Remember that these position parameters are 0 based. Refer to the datasheet shown on one of the previous screen. You will notice various parameters in that table. These parameters and commands for LCD interfacing are written in lcd.c file. We need not to reinvent these commands by writing our own LCD driver.